This is the daily video for July 1st. Today we're going to look more at experiments and data that comes from experiments. So as a reminder, experimental data is some of the best data that we can get when the experiments are performed properly. And usually when a scientist performs an experiment, they're trying to show that something causes a change or that one thing's different from another thing. And so when there are results that they find, so in other words, the results of the experiment, if we can prove using statistics that those results are unlikely due to chance, in other words, those results really are meaningful, that's what's called statistical significance. And whenever a researcher performs an experiment, that's what their goal is. They're hoping to find statistical significance. In other words, they're looking for proof that the results aren't just due to chance, that they really are meaningful. And so that's what the first video, or the first two videos, that's going to start talking about experimental data more and about this idea of statistical significance. And so the first example, or the first assignment you're going to do today is going to look at that. It's going to look at some data from experiments. It's going to have you identify what's being compared, whether or not they were able to reach statistical significance, and maybe some things that went wrong in the experiment. Now, when trying to prove something using experimental data, we saw before that this idea of randomization is very important. The second exercise you do today is going to look at this idea of randomization. And so I want to take the time right now to talk about that exhibit in the workbook to help you with it. So there are actually two types of randomization that can be done in an experiment. And the one that we've already looked at is what we call randomization to treatments. So in other words, think that you have a group of subjects and you're going to randomly assign each subject to one of two treatments. We do this type of randomization to reduce confounding, and that's what you saw yesterday. So again, anytime that we randomize a treatment to subjects, that helps us reduce confounding and hopefully prove causation. The other type of randomization that can be done is what's called randomly selecting a sample. So let me talk about that for a minute. Generally, when a scientist is performing an experiment, there's some larger group that they're interested in learning in. So for example, if I was a scientist and I was performing an experiment on a new heart drug, my overall group that I'm interested in would be anyone that would benefit from that drug. This large group that the researcher is interested in is what we call the population. And so the population is the large group that the researcher is interested in learning about. Now, generally what happens in experiments is that population, or that large group, is so big that a researcher cannot look at every single person in the population. So again, if I were a researcher and I were interested in anyone that a heart drug could help, you can see how that would be a very, very large group, and I wouldn't be able to perform an experiment using all of those people. So instead, what the researcher would do would take a small subset of those people, say maybe 100, and perform the experiment on them. This small subgroup from the population is what we call a sample. And ideally what the researcher wants to do is he wants to be able to take any inference he makes involving the sample and apply that inference to that large group that he's interested in. In other words, apply that inference to the population. In order to do that, we have to have that the sample is randomly chosen from the population. So when the sample is randomly chosen from the population, we're able to apply our inference, or in other words, our conclusions about the sample, to the entire population. And so that's what the second exercise is looking at. It's actually looking at the two different types of randomization that we can do. So kind of recap what I just said. The first type is to randomly assign treatments to patients. By doing this, when we randomly assign treatments to patients or subjects, we're able to reduce confounding and hopefully prove causation. The other type of randomization we can do is randomly selecting a sample or randomly selecting subjects from an overall population that we're interested in. When we randomly select subjects from the population, then what we can do is apply our inference that we made on the sample to our overall population. So notice here, it's possible for an experiment to have either neither of those types of randomization, one of the types of randomization, or to have both of those types of randomization. And depending on which types of randomization the experiment used is going to tell us what types of inference can be correctly made from the experimental data. And so you'll notice on that second assignment there's a little chart there, and that's basically what you're doing. You're comparing the different types of randomization that can be done in an experiment to the type of inference that can be made. And make sure you do read the instructions on this assignment, because there is a typo in that chart, and the instructions are going to show you where that typo is. So as always, if you have any questions, feel free to use the discussion board. I'll be monitoring it daily, and I will talk to you tomorrow.